Presentation is coming from Tim Carroll over at Microsoft. He's the director of HPC and AI for research. He's going to give us a great presentation today about the HPC cloud usage over there, and I'm sure Azure is going to be a big topic.
There we go. How's my audio?
Audio sounds great.
Okay. Do I look like a man who just had both computers reboot in the last 6 minutes?
Don't see any sweat, so it almost appears like you're used to it.
Who says Windows doesn't reboot quickly? Come on. Oh, me. It doesn't. All right, let me bring this up real quick and I'll just share. I can, excuse me, I can share, right?
Absolutely.
All right, so let's do this. Let me open a file here real quick. All right, you got me?
I got you.
All right, cool.
Great.
Good. All right, so without further ado, you want me to dive right in?
Yeah, please, Tim.
Okay. So first of all, A, thanks for the invite, and B, thanks for the patience. And I just wanted to take some time today. I go way back with Steve and Sydney and Gilad and most of the people out there. And there's been plenty of discussion about what people have done relative to COVID. And we did a bunch of cool stuff, and I was fortunate enough to be in the middle of it. But I thought for this audience, especially because this group has always been thinking about what's next for all of us, I just wanted to pull together what my experiences were with COVID, but also having been one of the early cloud HPC folks, and that journey from Dell to Cycle to Microsoft, pulled together, less so much how much cloud and HPC impacted COVID than COVID impacted cloud and HPC. And so I just wanted to be able to start off the conversation, A, with a title that would get people's attention. Importantly, so many times when people say, well, let's just worry about the science first and then we'll worry about the cost later, that's because it costs so much. Nobody wants to talk about it up front because they're afraid it'll scare people off. And the reality of it is that I've been doing this for over 20 years now. And the only thing that I know to be true, or I should say one of the few things that I know to be true about this space, is that the cost of compute never goes up, right? The reason we are all here is because on a per unit basis, the cost for compute and storage for the research community is so much less per head than it was 20 years ago or 10 years ago or 5 years ago. And that trend will just continue. It's economic forces, not benevolence, right? But I tend to step even further back, a little further back, not a little further, a lot further back than that. 100 years ago, ironically, in 1921, so Lewis Fry Richardson, who was one of the early guys in terms of computational science and especially in numerical weather prediction, I'll let you read it yourself. But basically what he said was, hey, look, won't it be a great day when the cost of doing compute is actually less than what it saves humanity and society, and therefore we'll be able to, it'll be an easy case to go afford it, but that is but a dream. And the reality of it is that when Richardson was talking about computers, he was talking about people. That was when people would sit and literally do hand calculations on all this. He hadn't even been able to envision the silicon revolution. But the reality of it is that we're pretty close, right? In terms of if you look at what the cost is, and then especially if you look at the two greatest threats to global security today, which are climate and health. If you look at the cost of us not being able to figure out how to solve for these problems, the cost of what it takes to actually solve it and solve it in time to do something about it is actually becoming trivial, right? Which hopefully will make funding easier, but I'm not sure that any of us can control the funding process, which is a completely different animal. And by the way, when I talk about this quote, I always throw out that I got it out of a book called The Weather Machine by Andrew Bloom, which as an HPC person is a great read. I think it's from Wired magazine, but in any event, he just got interested in weather. He wasn't a meteorologist or anything, and he dug down and he kind of figured out what it is. And so it's a quick read, but worth it. And if you're in the university system, give it to your students. So here's the first thing that I think that we need to be aware of, is that one, innovation is occurring more rapidly right now. Innovation as it relates to using cloud and the cloud-enabled tools from the big technology providers is occurring more rapidly in the commercial sector than it is in the public research sector, which has traditionally been, the public sector side has traditionally been where most all of this research has emanated from. But I'll explain that in a minute. And I'm also not saying public research is dead. There's a very real reason for this. And one of the things that I want to make sure I do is to give you a little bit of my background so you understand what the context is. Did the first commercial commodity cluster into DOE as part of Linux Networks in 2001. We did the first production cluster into the DoD's high performance computing modernization program as part of their technology insertion 02. And then Linux Networks, I went and I ran Dell's business, the business side of the business from 2007 to 2013, where Sydney Stevens and I became friends. And then left there because I had a sense of what cloud was going to do. And I'll circle back to give you the specific moment of why that was in a few slides. But that in 2013, I left to do a startup called Cycle Computing. And what we did was we orchestrated workflows that had been commonly running on commodity clusters, and we were able to migrate them over to cloud and then orchestrate them once they were there. As a result of the work that Jason Stowe and Rob Futrick and a bunch of really smart people did, we were acquired by Microsoft in 2017. And so I've been at Microsoft since 2017 and was very fortunate in that I got to pick what I would go do when I got here. And I love the public sector, right? And so I said, well, I would like to get my arms around helping us drive the Microsoft's support for public sector research, not just HPC, but what we can do to grow the research environment. So I've been doing that ever since. But you can't do what I do for a living and not get pulled into all this other commercial stuff, right? Especially when that's where the action's going on. But the reason that I call out the work that Microsoft has done with companies like Walmart, which was 2018, right? GM and Chevy Cruise, the relationship was just announced only a couple of months ago, but that's gone back years in terms of what the collaboration's been. And the same thing with Moody's taking some risk modeling tools and helping to cloudify them. But the reason that those are so important, right, is because they had a problem and a deadline that they were working against. These were purely, hey, here's what I need to go do. If I can do this, this is what it's going to mean to my business. And they could just sit down with us and try to go figure out how to make that happen, which is a very different experience and very different relationship than we have in the public side, right? Where there's a lot more construct around not only how the money flows in, but then it also flows back out to the vendors. But it doesn't mean that given some of those challenges, we're not able to innovate. Now, this is one of those ones where I'm just going to go ahead and throw up that if somebody wants to pick apart the specifics of any of this, I'm 90% sure they're right in whatever they call out and tell me that I'm wrong. This is one of those things that this is really about sort of being directionally correct because I was right smack dab in the middle of it, right? The top slide is the one that we've all seen, and it's the processor units shipped from 96 to 2017. Which is really the 20 years that you had that were really dominated by commodity clusters, right? And so if you look in that little timeline there, starting about 2002, 2003, that's when it really hit the gas. But if you also take a look at the underneath of that, is the cost per genome that was going down at the same rate that the market size for compute was going up. And the timelines roughly overlap. And, I will leave it to academics far more intelligent and analytical than I to be able to pull the one-to-one comparisons. But the reality of it is that I was running the business at the time. And what we knew was that something amazing was happening on the science side. And that because of what was coming off of those sequencers, and because of the research community's insatiable appetite for compute, that they needed a lot of compute, but they didn't necessarily need a supercomputer. Right at the same time, the Don Becker and Thomas Sterling and everybody else in the Beowulf project had figured out how you could run commodity clusters in order to execute against jobs like this. That's why we saw the explosion that we saw, right? And one of the things that happened that fueled the growth of commodity clusters just across the board, whether it was for something that was, at the time, people were even saying, well, genomics isn't even real HPC. But as the person whose job it was to try to figure out how to build a business, all of this, the amount of money that was flowing into businesses in order to fund being able to build computers that would meet the demand for that also gave us the ability to hire people and do R&D around things that could help us to build more performant machines, to get us into building capability, not just capacity machines. And so there is this relationship, if you look at what's going to happen between cloud and what happened historically with commodity clusters, that there are a lot of parallels and reasons to believe that you are going to see a similar hockey stick in the rapid growth of cloud adoption and just the millions or billions of core hours that will be run on cloud, much like we saw the same sort of up and to the right trajectory in commodity clusters. And there's another really important point of all of this, especially as the people who are thinking about cloud versus on-prem, which you shouldn't think of it that way. Everything that you see there in green is basically growing the market, right? So this tells the story of us getting more research, more compute into the hands of more researchers. Because look who the incumbent vendors were. They were the proprietary vector vendors, the risk vendors, the epic vendors. Their businesses grew too, right? So what we did when we were building COTS clusters did not come at the expense of the other vendors that ran good businesses with proprietary architectures, because they too were solving problems that couldn't be solved. And quite frankly, they were solving the problems that we within the commodity world were never going to be able to solve, right? Thank goodness for all of us that Cray thrived right out of this, that this gave the entire industry a shot. So in a very non-technical way, what was the fundamental difference between what happened with COTS that changed pretty much all of us? Anybody on this phone who's managing clusters, right, are the beneficiaries. Their career was the beneficiaries of that economic transition that occurred. But what's the difference? The difference is that when we moved from proprietary infrastructure into COTS, the budget model, how the dollars flowed from NSF and NIH, how you budgeted for it, how you procured it, the business model of funding and procuring HPC in the public sector didn't really change all that much, even though the technology and the architectures did, right? But the big difference between that and cloud is that cloud turns that whole model upside down, right? It is far more complicated to figure out how much it's going to cost you to run that workload than it is whether or not you're going to be able to run that workload, right? And that's a challenge for people who are scientists who might have gotten good at the compute, but the last thing that they want to have to become is economists, right? So in order for us to really embrace this and be able to move it into production at scale, we're going to have to solve for that problem, right? So But let me step back a second and let me use some COVID examples as to why I believe there's hope in all of this, right? And when I said earlier in my comments about what is it that I think that COVID did for the business, I will spare you all of the examples of, hey, here's all the cool stuff and all those other pieces that we did, because quite frankly, one of the neat things about being at Microsoft is that we have intentionally not talked about probably 2/3 of what we did. We made conscious decisions not to talk publicly about them, either because it may seem exploitative, but that was even less so. But also there were some times where we stepped in and did some very sensitive work in a very short amount of time. And it's not necessarily, that's not anything. Maybe we'll look back historically and look at it, but if you think at how wrought we were when the pandemic hit, with people just searching for answers across the board, and that nobody was really sure whose job it was to step up. I'll tell you, one of the cool things about being at Microsoft stepped up in a big way. So let me give you an example of what we did with Duke. So Amanda Randalls is the principal investigator, and Charlie Neifel, I don't know if any of you know him, but he runs the HPC infrastructure on the academic side at Duke. And we've been talking to Charlie for probably 18 months or so, because it made sense to look at cloud, and Microsoft already had some relationships with Duke and all that stuff that happens in the normal course of vendors and university research organizations working together. But on a Wednesday, earlier in the week, Dr. Randalls had approached Charlie and said, hey, we've got an opportunity to solve a very real problem here. And the very real problem that we can solve is that if you remember last spring, there was a critical ventilator shortage. People were deeply concerned about whether we were going to have enough ventilators, even with the Defense Production Act and everything else. And so a couple of researchers at Duke had figured out a way to do a ventilator splitter so that you could get two patients on the ventilator at the same time. And for a ventilator that wasn't necessarily designed to do it, what this was going to do was that it was going to balance out that flows to ensure that each person got the appropriate amount that they needed, but that also that it was balanced so that one person wasn't depriving the other. And so this was all done using modeling. They put together a prototype and some other pieces, but they could get it submitted to the FDA for emergency approval. But they figured that they were going to need somewhere, their count was somewhere between 500,000 and 1 million hours of compute in as short a time as they possibly could in order to get it in the window for the FDA emergency approval. So that was early in the week that Dr. Randalls went to Charlie. And Charlie looked at what his internal systems capabilities were and just didn't think that he was going to be able to pull that off with his internal systems, even though they had enough capacity on the floor to solve it. Anybody here that is either running on a shared machine or has to run on a shared machine knows that clearing people off those machines for the purposes of doing work is not always the easiest thing. And so Charlie called us, and that was on a Wednesday. And I'll just say, fast forward, by Sunday, we had done 800,000 hours so that we could do all of the modeling that was required for Dr. Randalls and her team to be able to get that into the documentation that they submitted at the end of the week, right? But where the COVID piece of this thing rolls in, and the reason that it's so important that public sector sees these kinds of success stories is that if there had not been a problem and a deadline, if Microsoft had not decided to participate in the White House consortium, HPC consortium, on which I was supporting that effort, we were fortunately in a place that when Charlie approached us and Dr. Randalls approached us, that we just said that when we saw problem, solution, time frame, we just said do it, right? Because we didn't know how much it was going to cost. We just knew that there was a big bucket of money there to go run that down. And nobody was thinking, well, you're going to do these 3 PR things and all the rest of the stuff. It was just do it. And we learned an extraordinary amount out of that effort, an extraordinary amount. But so did Duke, right? And so did other people. And so the lesson that we learned out of this, and as a result, we're now working with Duke on several things that dwarf this in size and scope, because their researchers are now freed up to understanding, hey, if I'm not bounding any of my science by what I think I can get access to, I'm just going to let myself go think, here's what we could do. And then we're going to work collaboratively with Microsoft to figure out a way that we could go do this and have it fit within funding models. So let's start with the science. Let's just do the science and then work it back into the business model. Because of what happened with the ventilator splitter, all of us together learned how much easier it is to just flip that process on its ear, right? And go end over end and now put ourselves in a position to really make a difference. But it's also, Microsoft can't be a charity forever. So we're working toward making this a model that works for both of us. Right? So I think it's also important to say we didn't invent collaboration. And here's something that's really important. And I want to go back to, I'd referenced the work that was done at Dell. This is still one of the things that, in my career anyway, that I'm most proud of the stuff that we've done. So TGen is the Translational Genomics Institute in Arizona. James Lowy has been, he started off leading HPC there, and I think he's either the CTO or CIO there now. But in 2011, in what was a similar model, they approached the Michael Dell Foundation, not Dell the corporation, but the Michael Dell Foundation, because they believed that they had line of sight to being able to solve for being able to do clinical trials by using genomics and then database comparisons to significantly minimize the amount of time that it takes to get to a treatment plan for a child diagnosed with neuroblastoma. But then also because of the way that the tumor boards had previously been done, by being able to accelerate the use of databases to get to what is hopefully also a more efficient answer and a better way to capture all that data to continue to get better and better at the process. So bear in mind, this is 2011. And so the challenge, which Glenn Otero, who was working at Dell at the time and now works at TGen, the challenge to Glenn was, hey, can you spec out so that we can figure out how to get enough compute into a single rack that we could get into, that would fit within the power envelope of being able to go into a lab environment as opposed to a data center. And that was an initial $4 million investment. The work was extraordinary. But also, if you go back to what I was talking about with Duke, here was a thing that had a problem, a solution, a timetable. Timing was important, right? And it was something where we could accelerate all of that with funding. And so we were able to go pull it down, right? And as a result of the success that came out of that, just like we're now looking at with Duke, there was follow-on because the initial problem that was solved had such clear quantifiable value that we were able to keep the Dell. I was gone, but Dell was able to keep that program going. And so, what's also really interesting about that, and I said that I would talk about it before, James Lowy is the person who got me thinking about cloud, because the original iteration of this in 2011, and it'll show you how forward-thinking James was that James was thinking you could use public cloud in order to be able to link together all of these pediatric cancer centers, because there was no way at the time through private networking you'd be able to move all that data in the way that you needed to. And so James was thinking about cloud in 2011 really as a network and transport vehicle, but it was as a result of conversations that he and I were having, which is to say, well, why wouldn't you just put the whole thing up there, right? And so it also shows you the unintended consequences or unintended benefits of getting in and collaborating and figuring out how you can go do something, but there are certain pieces that need to be there in order for companies and public research institutions to be able to work together. The other thing about this that I would just say is that because it was TGen and not University of or a federal agency, we also had some more latitude to do what we needed to do, right? So I don't think that there's this is something that Stanford could go pick up and do, or University of Nebraska or Georgetown or anybody else. So let me just step back and say why I think, or how I think that cloud, rather than us waiting for the next COVID, right? We don't have to wait for the next COVID. We have climate, we have ongoing health. There are other things that we can do, but I think that if not just customers, but vendors can take a step back and understand the relationship that we have and how it needs to change, for us to be able to figure out how can we accelerate the use of HPC in the cloud in the public sector while we're still somewhat handcuffed by funding and spending rules. The first off is that people have to understand going into this, regardless of what your senior most administrators or leaders think, that cloud is a process. It is not a system. You don't buy cloud, right? Cloud is something that is really going to require a rethink of how workflows down to the workflow level, down to the workflow level are done. That was my finger banging on the keyboard, right? So you need to sit down and have that conversation. The other thing too is that it's cloud and on-prem. It's not cloud or on-prem. I'm a cloud guy and I still want on-prem, right? There's absolutely a value for both, and nobody should waste any time trying to either figure out how to do it all cloud unless they have a compelling reason that they can't get a data center. But they also shouldn't spend any more time trying to prove why on-prem is going to be better than cloud, because that's a tough one to prove and it's going to get tougher every single day. The other thing is that the tactics inform the strategy. So much of what we've done as we've tried to go for grant money and these other things, when we were thinking about the big system, we try to sort of think of everything first because we have to, because if we haven't thought of it, we buy something and then we got to wait 4 years to buy its replacement, right? So we try to think of everything up front. Cloud gives us the ability to be a lot more iterative. So you need to go do it for a while in order to inform yourself enough to know what your strategy is going to be. You can't lead with strategy when it comes to cloud, right? The other thing is that burst to multi-cloud, which is some of the early RFPs that we've seen. I laugh. I've now finally been doing HPC long enough that even though my major was international economics and American literature, I think I qualify as an HPC guy. And we love to solve the hardest problem first, right? So we get these RFPs where somebody says, hey, yeah, we're going to go cloud. We think it makes sense. And what we want to do for our first iteration is we'd like to fund a pilot, so that what we're going to do is we're going to seamlessly burst from on-prem, and we'd like to be able to burst all 3 cloud providers. So you have just gone from playing tic-tac-toe to 3-dimensional chess, right? So this is not, again, where I said this is iterative, to try and go do all of that up front and then wait a year or 2 or 5 for that to be successful, you're losing valuable time that your researchers or you individually could be doing things that are creating value. Right? The other piece of this too is because there has to be so much more collaborative, because this is process driven, I'm not telling you who that partner needs to be. It might be a cloud provider, it might be a services partner, it could be your chip vendor, but find a trusted partner. And in terms of trusted partner, you're not going to be able to quantify a trusted partner with a spreadsheet. You're just going to have to find somebody to take this on with. It might be your application provider. It might be the person that, it might be the person who wrote it. I'm not sure, but find somebody that is going to be on the delivery side that you can do this with, because you're going to make more mistakes than you are do things right in the beginning. And so you just better know that they're looking out for your best interests, because that's how you're going to get through those pieces. And then the last piece is solve a problem with a deadline. And a little bit of this goes back to the strategy piece, right? Which is that if when we sit around and we say, we're going to sit down and write our cloud strategy, that thing's never going to get written because there's no stake in the ground, right? So you're so much better off making the decision as an organization that cloud makes sense, and then look for an opportunity to go demonstrate that, especially one that has a deadline, and even better if it's got something that you couldn't do on-prem anyway. And the good thing about doing that in terms of trying to figure out how to replicate it or get more funding or whatever else you want to do is that typically things that have a problem and a deadline are really important. So you get the opportunity to A, solve a real problem, and then go back once the problem is solved and figure out the lessons learned from that process. But you're going to learn a whole lot more in the 3 months or 4 months or whatever else it is that people go heads down to try to get that solved and then look back than if you spent 8 months thinking about hypotheticals and theoreticals. So this is not the Azure aren't we cool slide, right? I mean, we are pretty cool, right? And we're cool because folks like Evan Burness, who had run the private sector program at NCSA, is the person now charting out what our roadmap looks like going forward. Our roadmap is not put together by a system designer. Our roadmap is put together by a center director. And so we think about it in terms of what are the problems that we can go solve rather than who can build the most elegant widget. And so I'll just say that I'll open this up for questions in a minute. I'm happy to drill down on the specifics of this, and there's a pretty good chance that nobody's going to be satisfied with the answer that I give. But here are the two most important points of this slide, and they don't have anything to do with the numbers that are on them. The first is in the upper right-hand corner. Steve Scott, who had been the CTO at Cray, is now at Microsoft. And that's not, hey, aren't we cool that we got the CTO of Cray? It's more having his voice in the room is amazing at executive levels because HPC has, and he's not even dedicated to HPC, but HPC has a voice at the highest levels within Microsoft because we understand the value, not just of high performance computing because the workloads that we run are cool, but because we HPC people understand scale in a way that few people do. And that's going to be required going forward in an AI and ML driven world. And so for Steve to be there with that voice, to understand scale, both from a technical, but also from an organizational impact perspective, has been invaluable to us. So that's point number one. Point number two is let's take the Wharf example. The thing about running Wharf at 80,000 cores is awesome. There isn't the ability to run 80,000 cores, or we haven't seen anybody run it on-prem just because nobody can free up 80,000 cores on an internal machine. But the more important thing about the work that we did with Wharf is that there are 40,000 Wharf users around the world. And those 40,000 Wharf users could all rerun the benchmark that we did if they've got access to the internet, an Azure subscription, and the credits to go do it. Because everything that we use to run that benchmark, Hurricane Maria data sets, all the libraries are sitting out on azure.com. Everything there is replicable. Every single one of these benchmarks that you see is replicable by anybody who'd like to go do it, right? And so just to wrap that up, because I think this one's pretty cool too, I had the good fortune to be involved in the TGen example from 2011. Was that 10 years ago? Wow, 10 years ago. I had the good fortune to be in the middle of helping Duke out in the spring. And just recently, I don't know if anybody recognizes or remembers the name Mark Fernandez. He had been on my team at Dell. He's now at HPE. And just recently, we announced that as part of the Spaceborne 2 computer that Mark is sending up to International Space Station after a successful deployment of Spaceborne 1, we now have the ability to burst back to Earth and run workloads on Azure from the International Space Station. So where I was saying before that anybody who knows Wharf, the 40,000 Wharf users, as long as you've got an internet connection and an Azure subscription, and you've got access to those libraries, which people do, you can go run Wharf at 80,000 cores. Well, I used to say that anybody on the planet can do that. And now the reality of it is that anybody on the planet and in low Earth orbit can do that, because the astronauts on the space station now have access to Azure for the purposes of doing compute. Now, I have to say that I've always been, as Sydney will tell you, like I used to hate top 500. I just stopped doing it. I forget what year it was, 2009, 2010. People went insane. I said, it's a waste of time. It's not real science. All you're doing, it's a stunt, right? What we're doing on the space station is not a stunt. So one of the examples of work that they're working on is the ability, because there's also a sequencer up there. And if you think about somebody who's deployed on the space station, if you find a lesion on your arm and you want to determine whether or not it's cancerous, you don't catch an Uber back down to Earth, right? And so the ability to give that kind of capability to the folks on the space station, and then at some point when we've got manned or unmanned science centers sitting on the moon or Mars or other places, we're going to be able to use that capability either back on Earth or back at the edge. And so I'm hoping that 10 years from now, I'm still telling cool stories about the work that I did with Fernandez in 2020 and 2021 in the same way that I still look back at TGen. So I used my 35 minutes there. I hope this was a different perspective for folks who are trying to figure out, folks who are in that place of like, okay, I get it. Like cloud makes a ton of sense to me, but it's just hard in my environment to go figure out how we can really do this at scale. All I would say is that we know it's hard, but we're trying to figure that out, and we would like to try to figure that out with you. So happy to have that conversation. So thanks.
Thank you, Tim.
Oh, and I got to say, Steve, I love this slide because like, this is a Microsoft Can slide. This is like, as you can see from my background, that's not me. But one day I would love to be like that simple and that hip, but I'm not. So we'll use that picture though, but now we'll open it up for any stump the chump questions people want to throw at me.
All right. Well, we definitely have a few questions and we'll see how you do.
Fire away.
All right. So first one, has there been any collaboration between Microsoft and Amazon to make public available scientific data sets hosted on your clouds? For example, earlier today, Professor Bowman mentioned that folding at home produced 200 terabytes of data. If someone wanted to analyze that data, what's the most practical way for them to get it without needing to download it?
When I saw Professor Bowman was on there, I was like, oh man, I know where he's going with this, right? Because Jerming Cha, who was an old cycle person at Microsoft, he worked very closely with Professor Bowman on that stuff. I'll tell you, the reason I had the Fred G. Sanford heart attack when you talked about public data sets is that, I have friends at Google and I have friends at Azure and I have friends, that this whole notion of hosting these public data sets, I will say that from the research perspective, because we're working with both universities and NOAA and NIH and everybody else, I can understand how from the outside looking in, you're like, dude, you're a $1 trillion company. How can you not just take all of this data, chuck it up there so that researchers can get access to it? It's actually a pretty thorny topic because it's not a question of just getting it up there, because once it's up there, you've got to give people a way to access it efficiently. And that also, even if you look at the different cloud providers, we all have different ways that we charge for egress and these other pieces. And so this whole notion of data, like the compute's the easy part. The data, how it is that we, the cloud providers, are going to be able to get the right data sets up there that are most meaningful, and figuring out how to get the right data sets first so that we can demonstrate the value to all commercial cloud providers of putting that data there, is what's going to help us to do that most quickly. I think that we know that we've eventually got to get there to figure out how all that data eventually winds up in the cloud. But right now we're still trying to figure out how do you make the cost justification for that, because we're a publicly traded company, right? You can't just sort of waste money throwing stuff up there to figure it out. But at the same time, the easiest way to figure that out is to make sure that the data sets that we do, and we're in the process right now, we're moving data sets up there every day, making sure that the data sets that we move up there will have the greatest impact, not only to science, but also especially as it relates to climate and health, so many commercial entities that want to access that data in terms of driving productivity or insight or commercial value. Did that answer the question?
I hope so. He he has a follow-on question related to if NVIDIA A100s are currently available for use by the public on A100s.
So, Ian Finder, who's the product manager, I think he blocked me. I'm not quite sure because he's in control. So those are in preview. And is the question whether or not they're available
for public use? Yeah.
Yeah. Okay. So public, I swear, because I have a problem paying attention. I still don't understand what's public and private and everything else like that. But look, I put my email address there for a reason. Please just hit me with a question and I'll do my best to answer. But I know that we are in preview, and I still don't understand whether that means preview as in we have to give you the keys to it, or whether we've opened that up. I think we're still in the place where we've got to give you, the PIN code so that you can unlock them, and then we're probably a couple of weeks away from public preview.
Gotcha. Here's another one. Total wall clock time to solution is critically important to end users. So how does Microsoft guarantee on Azure that my time to solution 3 months from today will be guaranteed the same as my calculation today?
I would say we probably can't, right? And I'm not being glib, but I spent a long time with a lot of lawyers and a lot of finance people trying to figure out how we were going to meet the SLAs that people were giving us, the service level agreements that people were giving us. And those very people would say, and if you don't meet them, you don't get paid. And then we would say, okay, well, if that's the case, then we need to jack up the price another 10% to cover the potential risk, right? When you start getting into that, all of a sudden we start pricing ourselves right out of, especially what the public research community wants. I can only say, sort of with 15 years of experience of doing this, that if we don't continue the trend and meet that wall clock time on an ongoing basis, we will lose business. Because especially in the HPC community, they talk to each other even more so than other types of customers. But I would also say that being part of the roadmap process and everything else, that as we watch the difference between cloud and a static on-prem system is that, cloud, we are constantly upgrading everything about it on a quarterly or biannual, whatever basis. And so our business model is predicated on being able to continue to exceed the service level agreements that we've got with you, because we want to be able to solve your problem on less infrastructure on an ongoing basis, because that's actually good for us from a profitability perspective, right? So I don't think, if you're hoping to get an SLA from any cloud provider that says, I guarantee you will meet this in the following 3 months, I think it's going to take longer to get the contractual terms hammered out between the two organizations than it would to buy a cluster. That was probably not terribly diplomatic, but long day.
I know we're over time right now, so I'll end it here with maybe this is something you do know or not. Is Professor Bowman's 200 terabyte data set available for public use on Azure?
Did I mention lawyers before? I think you'd have to speak to Professor Bowman about that. But look, if there's one message that I would leave everybody with, and I really appreciate the time, and I hope this was helpful, because I know that you got a lot of very technical presentations today, is that look, Microsoft we've hired a ton of real HPC people over the last couple of years, right? And so it doesn't matter if you have a crazy idea. What the idea that to you might seem crazy might not seem so crazy to us, because we've got line of sight to things that you don't. But also some things that seem super simple may not be because of cloud. But the only way that you're going to know any of this is to talk to people like me or Evan or the person on your account team, the GBBs or whatever, because this is not like systems or boxes where you can just go pull down the specs and you can build your spreadsheet and you can compare it. You really need to thrash through this with people who that's what they do for a living.
Thank you, Tim.
All right.
Appreciate it. Steve, are you there? Do you want to close this out for today?
Oh, sorry, I had two mute buttons on. Hi Tim, how you doing?
Hey, Steve.
Great seeing you.
Great to be seen.
Yeah. I'd like to thank everyone for coming, especially Tim Carroll, whom I've known for probably a time too long to mention.
Exactly.
It dates both me and him.
You meet
Along
a lot
with
of
many others who
entities.
are on the call today. We've gone back quite some time. Greg Bowman back when he was at Stanford. Mike Houston when he was at Stanford. It's been quite some time. So I appreciate everyone for attending today. As you know, the HPC AI Advisory Council is an end user community. I've been happy to be, have been participating in it since its inception, and have hosted the conference at Stanford. I look forward to having everybody back at Stanford. Hopefully next year we'll open up and have an in-person conference. It may be one of the first conferences I'll actually attend because we're not doing any travel this year. But thanks everyone for joining today. If you have additional questions, you can either send them in chat, or I look forward to seeing everyone tomorrow for another great lineup of speakers. Brian, anything else from you?
No, that's it. Look forward to seeing everyone tomorrow, 10 a.m. Pacific.
Yep.
Thank you, everyone.